In this video, we're going to be talking about domain and range. Domain is the set of all input of a function or all possible x's. Range is a set of output for a function or all possible y's. So if we scroll down to our first example, I'm going to be listing the domain in blue. The domain is the set, if we put them in order, -1, 5, -1, 3, 5, 7. Range, I'm going to be putting in red every time. Range is red. That's going to be the set of numbers 0, 1, 4. There's another way to look at it. The x-axis is your domain. So if I drop all these points to the x-axis, these two get dropped to -1, 3. This one is right on 5, and this one gets dropped down to 7. So I have -1, 3, 5, 7. -1, 3, 5, 7. If I drop the points to the y-axis for range, I drop these two to the y-axis horizontally, and they end up at this point, 4. They double stack. This point goes to 0, and this point goes to 1. So 0, 1, 4. All right, so that's a discrete function. A continuous function are these. These are our parent functions, right? We have absolute value, we have quadratic, and we have square root. So we're going to be talking about all three of these in our next examples. In our first example, we have an absolute value. I want to make it clear that this absolute value goes on forever and ever, left and right, even though this is a partial graph. So when I go to list the domain, I can't really put a set of points like I did in the other example. I need to use an inequality to describe that, or an interval notation. So if I drop all these points, let's say there's infinitely many points on this, you would think that it only drops to, and I'm going to highlight where it drops to. It only drops to from here to here, correct? But these arrows indicate this function goes on forever left and right. So we have to extend this forever left and right. Well, when a function's domain drops to the entire x-axis, we can say from Algebra 1, hopefully you remember, that the domain is all real numbers. If we use set builder, or not set builder, if we use interval notation, this is negative infinity, and this is infinity. So we can say that the set of all x's goes from negative infinity to infinity. So in this interval notation, I use the ends to signify where it stops and starts. Now the range is a little bit different. If I drop those points, and again there's infinitely many points, to the y-axis for range, I'm only going to be able to drop it from here, but then it goes up forever too. So this actually has a stopping point right there. That point is 1, 2, 3 on the number line. Remember, y is for range. So I dropped all these points to the y-axis, and they covered here. Then I dropped all these points to the y-axis, but there's nothing to drop down here. So I have to cut off my range. I'm going to say that my range is x, or y, sorry, is greater than or equal to 3 on the y-axis. But I want to use the interval notation here. So I'm going to say my endpoints. This is 3 and this is infinity. So it goes from 3 to infinity and includes 3. So when a number is included in your set, you use bracket to include it. Notice I used parentheses because infinity is not included in the set. You can never get there. Okay, so that's the domain and range of this parent function. Let's go on to this quadratic. Again, I'm going to make it clear that this quadratic goes on forever and ever, left to right, keeps on expanding. So when I go to drop my points to the domain, blue, it looks like it only drops from here to here, but that's only a partial graph. We have to understand that it keeps on dropping forever and ever in both directions. So once again, we have all real numbers. So we can say all real, or we can use, and we should use, the interval notation negative infinity to infinity, not including both. So this is infinity, this is negative infinity, and it goes all the way across. Now our range is a little bit different. Our range only drops from here down and goes forever down. There's nothing up here to drop to the y-axis. Remember, y-axis is range. So when I go to describe my range, I'm going to say that my y's are less than or equal to 1, 2, 3 on the number line. But that's negative 3, right? Because it's below 0. Now, if I use my set builder's notation, here's what I'm going to do. I'm going to say that it goes from negative 3, that's the end of it, including negative 3, to, where's down here? Yeah, that's negative infinity. This is positive infinity, negative infinity. So negative infinity, not including. Next example, what kind of function is this? This is a square root function. And I'm going to draw my arrow to indicate it goes on forever, up and to the right. So when I go to do my domain, and I drop my points to the x-axis, I can only drop from here on. All right, so let's use set builder's notation to describe that. I'm going to say that it starts at 2 and it goes to infinity. Or I can say my x is greater than or equal to 2. Now how do we use the interval notation? Well, this starts at 2 and goes to infinity. So those are my two endpoints, including 2. All right, let's do our y's. Again, I'm going to drop them to the y-axis, but it looks like nothing drops down here. It only starts right there, and then it goes up forever. So where is that number? You're right, that number is 3. So I'm going to say my y's are greater than or equal to 3. Again, I can use the interval notation, starting with 3 and going to, you guessed it, infinity. So this is 3 to infinity. All right, we're taking a look at example 1. Here I have a log function. I want to draw my arrows indicating it goes forever and ever. Okay. And I'm also going to do something weird. I'm going to draw in its asymptote. Remember we talked about asymptotes? This is an asymptote that the log function approaches. the asymptote is y or x equals -3. That's the equation for this vertical dotted line. Okay, so there's my asymptote. Let's keep that in mind when I do my domain. Now it looks like my domain starts at -3. I don't have anything past -3. So my domain is going to be from here on. My range, on the other hand, starts down here, obviously. I'm going to move this. Starts down here, obviously, and then looks like it levels off there, but it really doesn't. It continues on and up slightly forever. So my range is actually the entire axis this time. So when I go to label my domain and range, let's do the domain first. I'm going to use this -3. I'm going to say my x's are all bigger than -3. Now, why didn't I include -3? Because -3 is actually the asymptote. It approaches -3, but it never really gets there. Set builder's notation is going to be -3 to infinity. Now we know it doesn't include infinity, and now we know it doesn't include -3 either. Let's do the range. The range is pretty easy. It covers the entire axis, so this is all real. If I use set builder, or interval notation, it's going to go from -infinity to infinity. This is -infinity down here to infinity. Those are my two endpoints. Again, you cannot include infinities.